Welcome back to the channel. In today's episode, we are going to talk about one of the most basic and most important concepts in machine learning, that is overfitting and underfitting. We shall also talk about bias-variance trade-off and some of the ways by which we can reduce overfitting. So what is overfitting? The model which is highly complex in nature and which fits the training data closely is an overfit model. An overfit model has high variance. Making a very small change in the data distribution would lead to a large change in the overall outcome. An overfit model tends to have a higher accuracy in the training data, whereas very low or poor performance on the test data. Okay. An example of an overfit model could be when we take k nearest neighbor with k equal to 1. That would lead to an overfit model. Whereas underfitting is an oversimplified model which is having high bias, or which makes a lot of assumptions. Okay, an underfit model, for example, could be k nearest neighbor with k equal to 10. Now when we talk of bias and variance in terms of overfitting and underfitting, let us understand that bias refers to the phenomenon that leads to skewness in the outcome towards a particular outcome of the model. Okay, so generally a model having high bias tends to make a lot of assumptions. For example, linear regression. Linear regression follows the assumption that the data is linearly distributed. However, in most cases it would not be. An example of low bias model in general is decision tree, whereas variance refers to the variability in the overall data distribution, or for example the model that we are building, how resistive or how well the model could adjust to changes or slight changes in the data. That refers to the variance. If we talk of the overall error that generated by a machine learning model, it could be divided into three components. First is the irreducible error, one which cannot be reduced even after changing the parameters and various other components. The other two are the bias and variance components. Okay. So we understand, like, when we talk of bias variance trade-off, we ideally want the model to have low bias and low variance. That would lead us to a more perfect model that is generalizable over the test data and has higher accuracy or better performance. Now talking about some of the ways by which we can reduce overfitting is cross validation, okay, bagging. Apart from that, we could also take the examples of early stopping. We shall talk about these in detail in the other lecture, but before that, if you haven't subscribed to the channel yet, do subscribe now and press the bell icon. See you in the next lecture. Bye bye.